Greetings! In today's video, I am going to explore how I created a logic system of a simple drone. So this is the logic system. It is not particularly complicated. Let's start out. So, starting from the front, I have a distance sensor that is always on. It gives a constant output, and it feeds into this XOR gate. This XOR gate basically activates everything. This is implemented because there's an issue with detachable blocks that I found, by which if two pieces are connected by a detachable block, and one of them has a constant output into its own parts, such as these steering hinges, once the detachable block detaches, the steering hinges will stop receiving the output from the distance sensor. So I worked around that by having them be keyed into this XOR gate, which receives an input from a distance sensor that's on the main body of the creation and counteracts this output from the distance sensor, in order that everything activates only once the creation is properly detached from the main body. Moving forward, we have a compass and two angle sensors. These feed outputs into the corresponding color of XOR gate, which also receives input from the XOR gate, which is activated by the distance sensor. So once the creation is detached from the main body, these three XOR gates will have a constant output from this distance sensor. This means that, for example, in the case of the compass, whenever the compass is not active, the XOR gate will be active. Therefore, if the compass is feeding a positive output into this helicopter engine, whenever the compass is not active, this XOR gate will be feeding a negative output into this helicopter engine, therefore acting as if there were a different compass that were opposite to this one. Exactly the same goes for both of the angle sensors into these two XOR gates. And exactly the same is for all of the speed sensors. This speed sensor will give an output into the XOR gate and into the thruster, and this XOR gate will give an output into the other thruster whenever the speed sensor is not active. The same goes for this speed sensor and this XOR gate. These two XOR gates control the drone's movement in the forward direction. This XOR gate, on a timing and a delay, will give the thruster facing backwards the output to push the drone forward, and at the same time, this XOR gate will give the forward-facing thrusters a negative output so that they don't stop the drone, allowing it to move forward. And then this rotating servo will have the compass atop it and will rotate on a timing so that once the thrusters have stopped pushing the drone forward, the drone will be able to rotate, thus creating a sort of a triangular pattern. Move forward in one direction, rotate, move forward in a different direction, rotate, move forward in the last direction. Lastly, there are the green parts, which are all made to keep the drone afloat. So the drone stays floating through a gimbal jet, through a distance sensor that senses the ground, and through a speed sensor that stops it from falling out of the sky if it is really high up. they all give outputs, both of these give outputs into the gimbal jet, and then the last thing that gives an output into the gimbal jet is an altitude sensor, so that if the drone goes over water, it will not sink. Those are all of the components that go into the drone, and now I will showcase how it functions. So this is the assembled drone. As you can see, everything is not active. Like the hinges and the lights are not active. The helicopter engines are kept at a certain speed so that they don't have to spool up from 0 once the drone is released. However, that is not as important as I made it out to be. That is actually quite unnecessary. And I will now release the drone. It will take a moment to stabilize itself. However, as you can see, it moves forward. Then it will rotate. Then it will move forward again. Then it will rotate again. And it will keep repeating this pattern. It's not a perfect triangle. However, that is basically intended because I do want it to feel a little bit random. I do not want it to feel like it's simply repeating the same trajectory over and over again. I want it to roam. I want it to feel like it's making some sort of an automatic decision by itself. Since I am already discussing logic, I figured why not talk about this logic system. So this is a selector. It allows for the user to decide which turret to make use of through the same controls. So essentially, when the lights are blinking on one side, that is the turret that is being made use of. And with the arrow keys, as you can see, I am able to control the turret. Then once I press 2, it switches control, still with the arrow keys, to the other turret. And then with the press of 1, it allows for the turret with the blinking lights to have access to its camera. And 1 again will take me out of camera mode. However, if I am in camera mode, pressing 2 will swap me over to the turret to the other turret, which now has its blinking lights, which I now can control with the arrow keys. The way I did this is, these are the arrow key controls. These are the arrow key controls. They feed into these 4 on both sides, which are connected to this selector, essentially. There's a distance sensor that hooks into AND gates and XOR gates, right? Both AND gates and XOR gates are also hooked up to this 2 input, like input on the button 2, which means that if the distance sensor is the only thing giving output, then the XOR gates will be giving positive output, therefore activating one part of the system. Instead, if the distance sensor that is always on and the XOR gate with output 2 are both giving outputs, then the AND gates are going to be the ones giving an output and therefore activating the other part of the system. This will allow to activate the 2 cameras and will essentially allow for the system on one turret and then the system on the other turret to be active. So yeah, it's not particularly complicated and it works quite well, and I am proud of it. And there you go. This is how I constructed my drones and assorted other logic systems. I hope you've enjoyed. Thanks for watching, and I will see you in the future.